Hello guys, hope you're doing well. And as always, if you are new to my channel, I would humbly request you to subscribe to my channel so that you shall be able to get all the related engineering videos that I will upload on my channel for you guys. Thank you. Okay, the problem at our hand today is basically we have to a problem, a spring-based problem, and in that problem, if you look at it, we have two springs. This is one spring, and this is the other spring, and those two springs are showing the two conditions of deformation. This is the initial state, and then there are two loads being applied at these 2 points, and it is going to the final state. Okay, so let's start the problem. He says determine the mass of each of the two cylinders if they cause a sag of s equals to zero point 0.5 meters. So this s is zero point 0.5 meter basically when suspended from the ring at A and B positions. And he gives you a very important hint that the value of S equal to 0 when the cylinders are removed. When this cylinder and this cylinder of the two springs are removed, these two springs goes back to its initial position, which is this and this. But it will only happen when this value of S becomes 0. Okay, so we know that the initial condition from A, from this point, this is also A, okay, from A to C is nothing but it is the hypotenuse length. And we also know that from this point to this point the length is 2 meters, and from this point to this point to this point the length is 1.5 meters. So we can very easily calculate the initial position of the spring, the length of the spring when it is in the initial state, when there are no loads are being applied. So we know this length is 2 meters, and vertical length is basically 1.5 meters. So we can write this, we can say very easily here that we can say that the undisplaced length, undisplaced length of spring, the undisplaced length of spring is going to be 1.5 meter, 1.5 meter, and this is 2 meters. So again, this is a triangle. Two lengths are given. The perpendicular and the base is given. So we can easily calculate from the hypotenuse length will be from the Pythagoras theorem will be 2.5 meters. It will be 2.5 meters. And we also know when the spring is being displaced by the application of these two loads, which are these ones, this one and this one. Now the vertical length of the spring after displacement will be 1.5 plus s, which is 0 0.5. So it will be 2, and the horizontal length will also be staying the same, which is 2 meters after the loads being applied. Okay, so we can also calculate the final length. We can also calculate the final length of the spring. The final length of spring will be uh, 2 meters. This will be 2 meters. So again, from the Pythagoras theorem, we can easily calculate this length. The hypotenuse will be 2.829 meters. So now we have the initial length and we also have the final length. Now we can calculate how much the spring deforms when the load is being applied at A and B. So just to let you know, we are only going to take the left side and solve it. and whatever results we get, you can double it, and you will be getting the same results on the other side also. Okay, so it will be just a reflection. If we get any value, you can use the same value for the other point also, because there is symmetry. The the springs have the same stiffness. The geometry is also very very similar. Okay, and from this we can assume that whatever the mass will be the spring at point A, the same mass will be at spring B, because similar geometries and similar spring stiffness means the same spring is being used. So we can write here the spring deforms, the deformation of the spring from F equals to K deforms uh, by, we can say, uh, TAC, which is the tension AC, is equals to, we know it is going to be K times X because it's a spring. So it implies that K is given to us in the question, and the K is basically 100 Newton per meter. So we can cite 100. What will be the deflection? What will be the final length we have calculated of the hypotenuse of the spring? 2.829. And what will be the initial length from the hypotenuse? It will be 2.5. So we can get the spring force, which is nothing but TAC, equal to, after calculation, we get it as 32.84 Newton. 32.84 Newton. So now we have got this spring force as 32.84 Newton. So just considering, as we have told, we'll consider the left hand side. So we can say over here, uh, we can say this is our point A. This is our point A. Okay, this is going to be our spring force, which is nothing but it is TAC, the final position of the spring, and we are interested in the angle. We are interested in this angle, which is theta. We are interested in this angle theta, and we can easily calculate theta. Just to let you know, this is 2 meter and this is 2 meter. So what will be this angle? What will be this angle? This angle, since the base and perpendicular are same, so if you apply tan theta, we know we will get an angle of 45 degrees. So we can easily say this angle will also be 45 degrees. And what about the weight of this spring? What will be the uh, basically the mass of this spring will be, we can easily calculate it as, we know it will be a weight. So we know weight is nothing but mg, so we can write it as m into 9.81. Okay, and just to let you know, we already know this is our x-axis, and on the horizontal side there will be, because this is a cable, so this cable will have some tension. So this tension will be, uh, basically, this is going to be T A B. Okay, so and this point is A, what they have already said, we're considering A point. So here, if you look at it, we are interested in basically calculating the mass of the spring at point A. So even though we have forces along X, TAB, and the horizontal component of TAC is there, but we are just going to calculate sigma Fy. So we want the mass of this cylinder A. So we will write it as sigma Fy is equal to 0. And remember, this is my positive y-axis. This is my positive y-axis. So if we apply the sigma Fy condition, we can very easily calculate. We know this vertical component will be basically nothing. It will be TAC sine 45. This component, this is going to be the vertical component, and and this component will be written as uh, TAC sine 45, TAC sine 45. And what is the other force that is being there, since this is positive, okay, but this weight of the cylinder is in the negative y-axis, okay. Remember, this is our negative y, so it will be written as simply minus m into 9.81 is equals to 0, okay. We can write it like this. Once this is being done, we have the equation. We know what is TAC. TAC is nothing but 32.84 into sine 45, which is 0.707, minus m into 9.81 is equal to 0. So from here we can calculate our mass of the cylinder at A. Mass of the cylinder, you can say at A, because there is B also, is equals to simply 2.37 kg. Okay. Similarly, mass of the cylinder at B will also be 2.37 kg, and tension BD will also be 32.84 Newton. Okay, so I hope this concept is clear to you as far as this problem is concerned, and I thank you all guys for seeing my lecture of this spring problem. You have a wonderful day.